algebraic properties, like how to simplify an expression, right? So for example, try to take the commutative property. Commutative means what? When you are going to take two variables a and b, your result should not be modified when you are going to perform b and a operation, or a or b is equal to b or a. This is what commutative, right? How can you prove that? How can I prove that? See, if I am going to take two variables a and b, whose inputs are 0, 0, 0, 1, 1, 0, 1, 1. What is AB? AB is 0, 0, 0, 1. What is BA? BA also 0, 0, 0, 0, 1. So I can say that these AB and BA are commutative to each other. B are commutative to each other. Okay. If I am going to work with the OR operator, A or B, B or A. A or B is what? When both are 0, 0, then the result will be remaining will be high. B or A also the same thing. So these two are commutative to each other. That is the meaning of commutative. Okay. Another kind of property is there, idempotent property. Idempotent means when you are going to take a variable A, if you are going to perform AND operation with the variable A, your result will be also be A. Or if you are going to perform like this, A or A, you are going to get A only. See, why you are going to get this one? If you are going to have a single variable A, what are the possibilities of Boolean values? 0 and 1, right? If you are going to perform A and A, what you are going to get? 0 into 0 is 0, 1 into 1 is 1. So are you going to get the A or not, right? This A I can write as A only. That is what I say, right? A plus A is A, because 0 plus 0 is 0 only, 1 plus 1 is 1 only. So that's why which is equivalent to A. So that is the property of idempotent. That's the reason in earlier equations also, x into x I have written as x only. So A into A I can written as A only. Okay. So you can able to observe some kind of properties, complement form, right? If I am going to take x as one variable, if I am going to perform OR operation over the another complement of the variable, then your result will be 0. If I am going to take x as one variable and on AND operation, its complement is 1. X into x complement is 1. Is it correct? Just think. Try to take the variable x, 0 and 1. X complement is 1 and 0. 1 and 0. What is x plus x complement? 0 plus 1 is 1. 1 plus 0 is 1. Right? So on plus, you are going to get the result as not 0. Going to get the result as 1. On AND operation, 0 and 1 is 0. 1 and 0 is 0. So your result will be 1. So always it is going to be satisfied. Okay. Similarly, we have another kind of properties there. Plus, like this, we have various kind of properties are there, right? How they are getting? Because of they are going to get certain kind of satisfactions of the properties, right? So when you are trying to solve your equation, you need to use these things. Identity properties. X plus 1 is always 1. X and operation with 0 is always 0. Similarly, x plus 0 is x. X and 1 is itself is also x, right? How we are going to get? Again, try to draw the truth table and you will get the same answers. Okay. And one of the main important property, associative property, right? If you are going to take x plus y plus z, which is equivalent to x plus y plus z, right? So this is what associativity. Or on OR operation, x into y into z is equivalent to x into y into z. So how we are going to prove? Take the three variables x, y, z, 0, 0, 0, 0, 1, 0, 1, 0 and so on. you can able to derive the value of LHS, you can able to derive the value of RHS, and you can observe the last two values are same. Hence, I can say that this expression is associativity. Expression is associativity. Okay, fine. See guys, here sometimes I have taken A, or sometimes I have taken X, sometimes I have taken some other variable maybe. So all having the same meaning. So where everything is represented as a constant variable, Okay, you may observe one basic important property, that is distributive property. Distributive property means x into y plus z equal to xy plus xz, meaning that I am trying to distribute the variable x over the inner side, xy plus xz. Or you may observe x plus yz is equal to x plus y into x plus z. These are two distributive properties, right? So if you observe, this expression is already derived, right? X plus y into x plus z is relating to what? X plus yz. X plus y into x plus z is relating to x plus yz. So these two will becomes under distributive property. And certain kind of properties are there. Absorption property is there. Absorption property, meaning that if you are going to have x plus xy, you can write it as x, right? Why guys you can write it as x? If you are going to take out the common as x, you will get 1 plus y. 1 plus y. What is 1 plus anything? You can observe here. 1 plus anything is 1, right? So x into 1. X into 1. So here, according to the rule of identity, you make it as 1, right? What is x into 1? X into 1 is x, according to the rule of idempotent. X into 1 is x, so according to the rule of identities. So are you going to get the same result or not? Yes, this is what one kind of absorption rule. Okay, you can write take x into x plus y, which is also yielding to x. Okay, x into x bar plus y, which is equal to xy, right? You can able to solve these two, right? So x into x plus y, is it equivalent to x? Why so? Try to check. So if you want to prove, you can take out the truth table, or you can go with the various kind of formulas what we discussed, right? So if you substitute here, if you take x of x plus y, right? If you are going to apply distributive property, x if you are going to distribute it to inner side, you are going to get x into x plus xy, right? X plus xy. You can take out the x as common. Again, you are going to get 1 plus y. Again, you are going to get, so you are going to get the value. Right? Similarly, you can able to try to solve this one. This also comes under absorption law. Or you can take out x plus x bar y is equal to x plus y. Guys, you can observe. Here one thing. What are the formulas that I am trying to discuss? See, it's not a magic. I have taken intentionally. Try to take out. These two are almost similar, but wherever they are using plus operator, they are using dot. Wherever they are using dot operator, they are using plus operator. That's it. Here you also can able to observe. Wherever they are using plus, they are using dot operator. Wherever they are using dot operator, they are using plus operator. That is what I can call it as duality. That I will discuss later part. Okay, fine. This is what the rules of absorption. And if you take out one more kind of a theorem, that is consensus theorem, consensus property. Okay, so consensus property is defining that if you are going to have two variables x and y, x bar z, yz, you can able to simplify it as xy plus x bar z. These two are equivalent. This is the meaning of consensus theorem, right? How we will get this one? Try to solve xy plus x bar z plus, guys observe here, yz, can I write it as yz into 1? Yes, right. In place of 1, I will make write off as x plus x complement. What is the meaning of 1? Can I write like x plus x complement as 1? Yes. Based on the complement rule, I can make it as like this. Right. Now try to distribute it. Try to distribute it. xy x bar z x bar z xyz x bar yz x bar yz. Now try to check these two equations and try to check these two equations. Right. So from these two, if you are going to common xy, 1 plus z is one thing, plus from these two, if you are going to common x bar z, you are going to get 1 plus y. What is 1 plus anything? 1. That is xy. X bar z is 1. So your result will be xy plus x bar z. So this is the property of consensus theorem. Or how we are going to prove this? You can able to take the truth table and you can able to solve it. Okay. Similarly, one kind of property is there, De Morgan's law or De Morgan's property, right? So the thing is, if you are going to have AND operation over two variables with complement, you can able to get as x complement plus y complement. This is very important. Okay. And if you are going to have OR operation over two variables, and if you are going to have complement, you can write as x complement dot y complement.